here I am going to talk about the second use of data-driven battery management. How can we reuse the lithium-ion batteries of the electric vehicle? So when we talk about circular economy, we talk about 3R, that is reuse, repair, and recycle. We rarely work on reuse of subjects. Like Cummins have a big factory in Maharashtra where they recycle the engine, they reuse the engine, that means they refurbish the engine and then sell them again. And similarly, we do repair our vehicles regularly, but when it comes to recycle, now our government has mandated that recycling, and a big recycling plant is coming up in Gujarat. So we are moving towards area where we give minimum impact to our Mother Earth and environment. And for this, we need to focus on areas like regeneration or improving the efficiency of all the components which we are using. So the end goal is moving towards sustainability and giving long-term value to the every components which we use. So let's take an example of a battery where we mass-produce batteries. Today we don't produce cells in India, they are imported and we just assemble them, but I am sure very soon we will start manufacturing cells in India also. And then these new batteries are fitted on electric vehicle. These are very costly battery which costs around 40% of the cost of the electric vehicle. For example, a Tata Nexon battery costs 7 lakhs rupees. And when you use those vehicles for 5 years and you decide to sell it to somebody, that somebody is not sure how long this battery would work. And if it stops working the next day, then he has to spend another 7 lakh rupees. So he always has a fear that why must I buy a second-hand electric vehicle? Who will give the guarantee of the battery? So we have developed an app which can tell the life of the battery, and then it becomes very safe. So whether it is a reseller market or whether it is an insurance company, everyone can use this app to find out what is the balanced life of a subject battery. So once the battery is old, so in electric vehicle the problem is that once the life of the battery is reduced by 20%, that means it still has a life of 80%, we have to stop using it, looking at the performance requirement of a vehicle. So we cannot throw away a lithium-ion battery into the atmosphere where its life has gone is only 20% and 80% is still there. So we have to work on reuse, and that is what I advocate, that we need to start working seriously on reuse of battery. I will tell you what are the ways by which we can reuse the battery. So that is one area, refurbish the battery and reuse, or directly reuse for other application. Recycling must be the last thing to happen, but when we want to recycle, there are different ways by which we recycle. One is we extract important metals like lithium, cobalt, nickel, and then reuse them, or we crush the entire battery into black powder, and then what we do today is we just export those black powder and somebody else is extracting the material. For this, it is necessary that we must be able to repurpose the retired EV battery for renewable energy storage also. So whether it is solar energy, wind energy, there also whatever energy is produced can be stored in such batteries. And for this, we have to design vehicles for SAM, that is serviceability, accessibility and maintainability. That means I must be able to remove the battery easily. If required to do a swapping, I must be able to do a swapping. Otherwise, I must be able to remove the battery, put another battery and go ahead and with the reuse or repair of the battery. So this, when we design an electric vehicle, we have to take care of this. This will be the base for circular economy as far as EV is concerned. So let us look at how can we reuse the batteries. Before we reuse the battery, as I told you, we must understand the health of the battery. So we need to use advanced diagnostics to evaluate remaining capacity and the health of the EV battery at the end of their first life. And then categorize this battery depending on its health, whether it can be used for energy storage, for solar and wind, or it can be used for lower power application like UPS or inverter at our home or office. So here you can see the repurposed battery are divided into three parts: stationary energy storage, or a backup power system, what I said as an inverter or UPS at our home, or it can be used for rural electrification through microgrids. So these are the ways by which we can reuse the battery. For example, at the airports, you may not be knowing that most of the airports are using lead acid battery, and they just throw away those battery after 3 years. But if we use lithium ion battery, reuse lithium ion battery which are coming out from the car, then those may last for at least 5 years. So their cost will come down because they are going to buy a second-hand lithium ion battery, and that can give a performance better than a lead acid battery at the airports. We need to develop an efficient collection system for retrieving the retired EV batteries. So how these batteries after completion of 20% of its lives can be retrieved, how can it be collected and kept in one place. And then we need to partner with recycling and refurbishing facilities to optimize the reuse. So we can refurbish and then reuse or directly reuse. We need policies from the government and incentives to ensure that we can use battery for the second life. And yes, there are extended producer responsibility EPR which needs to be refined, and we need to work in this area. So there are various ways by which you can recycle battery. Most of the methods are pyrometallurgy and hydrometallurgy. Pyrometallurgy is one proven technology which can directly recover nickel, cobalt, copper, lithium by heating the battery. So you heat them at a very high temperature and extract this metal. But it is very energy intensive, a lot of energy gets into it. So we are trying to generate energy from reuse, recycle, but we are also using a lot of energy. So most of the people are using hydrometallurgy, which is less energy intensive, so much energy is not given, but we can recover everything, but this is recovered through chemical leaching. However, there is a third method also available which very few people think about it, and that is called direct recycling. That means whatever damaged batteries are there or whose lives have reduced, we can take the anode and cathode and reuse it. We need to refurbish them, or we need to do an additional coat and then reuse it in our battery. So these are some of the methods by which you can go in for recycling of the batteries. So we talk about sustainability, and we know that mobility has become an essential essential part of our life. Whether we need to move ourselves from home to office and back, or we need to move a lot of goods, whether it's milk or vegetable or big good items. We require mobility. Mobility has become an essential part of our life. But mobility brings a lot of issues, whether it is accidents, whether it is related to safety, whether it is related to emission, noise. We need to work towards it. We need to find sustainable solution for this. And a best sustainable solution, or we can say the mobility is sustainable if we take care of these 3 P: profit, planet, and people. That means there is an economic growth of the country. Automotive industry contributes to around 8% of the GDP of the nation. There must be environmental improvement. That means we need to have BS7 norms to reduce the emission drastically. We need to reduce the noise emission. We need to work on end of life. So all this we need to work towards to ensure that we don't load our Mother Earth, or we take care of our planet. And third is there must be a social progress, that is you and me are getting jobs out of this. Millions of people must get job out of it, and then it becomes a sustainable mobility. By taking care of this 3 P, we are satisfying the bottom of pyramid of sustainability. So if you look at the prevailing conditions, crude petroleum prices are fluctuating and increasing. Petrol and diesel are more than 100 rupees per liter, and we need to move away from them, and hence our country is working towards alternate fuels. So LPG, CNG, biodiesel, ethanol, methanol, all of these are being used. Now we have added electric vehicle, and in future we will also use hydrogen as an ICE for our fuel cell application. So we need to move towards petrol and diesel, away from petrol and diesel, and move towards other diversity. Also more and more people are shifting towards city. It is said that by 2050, more than 50% of the population would be in the city. So we need to develop more cities or we can say we can develop smart cities. Probably the people who are sitting in, who are staying in bigger cities may shift to smarter cities, and the people who are in rural area may shift to the bigger cities. But we need to work on this. And the second area is that we need to ensure that the density of the vehicle is lower in the cities. For example, Pune is the country last year where the vehicle population has surpassed human population. Same thing is going to become to Bangalore and other cities also, and we have to be very careful in this area. So we need to expand those cities from all the sides so the density reduces. But this higher density will lead to a lot of time loss, lot of safety issues, and noise and pollution. And we also need to work on areas where we are producing less CO2. So carbon footprints are very, very important. We need to calculate carbon footprints at each and every stage, whether it is during production, whether it is during transportation, during usage, and during end of life. We need to ensure that we have minimum carbon footprints. And if we are able to do so, then we will be able to drastically reduce carbon dioxide. If not, then you know the situation that we are already living in almost throughout the year. It is summer, it is very hot. During summer, the temperatures are between 40 and 50 degrees in various cities. And if we continue at this way, then it will be more than 50 degrees. It will be unbearable for us to live on this earth. So we all need to be serious to move towards this circular economy and reduce this global warming. And this is possible through government intervention, which is happening. Our Prime Minister has already committed that we will be net zero by 2070 and will become Atmanirbhar energy independent by 2047. So policies have to be created which will reduce the emission limits, which will limit the CO2 emission limits, and we need to globalize with international standards, harmonize all those standards and move towards. So FAME is one such area where government has done a good job. Faster adoption for manufacturing of electric and hybrid vehicle, and lot of schemes have been there where we get subsidy when we buy an electric vehicle, and the GST is also reduced from 18% to 5%. So this entire prevailing condition makes us understand that electric vehicles needs to be here. So electric vehicle has become the face of the new mobility, which will drastically reduce carbon dioxide, at least in the cities. Overall pollution level will come down, carbon dioxide level will come down, global warming will come down. India produces more than 25 million vehicles every year, out of which 75% of the vehicles are two-wheeler, but we are now the third largest passenger vehicle manufacturer in the world, and the highest two-wheeler and tractor manufacturer in the world. From that point of view, we need to move towards sustainable mobility. So electric vehicle is one such way by which we can, in future we will have hydrogen in fuel cell also, and we are very lucky that government has come out with various measures to support electric mobility. However, it is not moving very fast. In three-wheeler, we have been able to reach a penetration of 50%. In two-wheeler also it's moving fast. Last year it was 2%, now it is 8%. However, in passenger car it is still less than 2%. We all need to work towards that, and there are many issues which we need to resolve. If you look at well-to-wheel emission of various vehicles, and if you take a typical gasoline vehicle, it will emit very high CO2 and NOx emission. But if we use electric vehicle, where we charge our electric vehicle using energy from the grid, then carbon dioxide will reduce to 1/3, NOx will also reduce drastically. But in case we use sustainable energy, that means we use electricity which is produced through solar, wind and hydel energy, then CO2 is zero, NOx is zero, and then that is real sustainable way to reduce the overall emission and also the carbon footprints. So battery costs are very high. With mass production and with internal manufacturing of cells in India, I am sure this cost will go down. Electric vehicle would become cheaper and more people will start buying. Yes, there are fear like what will happen if there is no charge and I am on the highway, or what will happen if my car catches fire. So we need to do lot of skill development and awareness to ensure that this fear goes away and people start buying electric vehicle. Yes, we need to work towards a better technology so that this fear disappears. So let us look at the value chain, electric vehicle value chain. We are buying lithium from outside. Up till now, we are buying from China and then Korea and Japan. Now we have tied up, our Niti Aayog has tied up with Bolivia and Argentina, and we will be getting lithium from there. Yes, we have some reserves of lithium, but they are unexplored and not much in enough quantity. When the entire country moves towards electric vehicle regime, then we will require a lot of lithium. So this lithium has to be imported, and then we need to make those cells and check the quality of those cells, use it in automobiles, and then we also move towards circularity, where we talk about reuse and recycling also, right? So we will have to set up a strong network value chain of electric vehicle and their components, and I'm sure government would support this. Lack of availability and sustainable supply chain of key element required for the ecosystem. So government has understood the problem, the lacuna in the supply chain, and it is supporting this entire ecosystem of EV. And if there is not adequate supply of domestic cells and battery, India will simply go from being an oil-dependent company to a cell-dependent company. So up till now, we were dependent on petrol and diesel and crude petroleum with OPEC countries. Now we will become dependent on countries who are going to supply us cell. So it is very imperative that we need to start producing our own lithium-ion cells. So developing an ecosystem of battery manufacturers by incentivizing them is the way to go, and this is what is happening. I am sure within a couple of years, we would start mass production of lithium-ion cells and other material cells, and then we will become Atmanirbhar. So here, if you look at the battery, as I told you, if the performance of the battery reduces by 20% or the capacity of the battery reduces by 20%, we say that's the end of first life of a lithium-ion battery, at least for the automotive application, right? And then there are many fire cases happening. We need to understand that it's not only in India, worldwide, Australia, USA, UK also, such cases are happening. We are trying to find out the root cause of this fire. There are many reasons. You can see here the causes for this fire, but more than 50% are still unknown. And this is all possible if you are able to characterize each and every cell of that battery, find out the difference between those cells, and find out remedial measure at the design stage itself to produce better cells. And this is what is the missing link. We have been doing all these efforts for the best performance of the battery, but we are not able to fill this gap because there are so many unknown in this area, and that is possible if we are able to characterize the cell. So characterization of cell is the area on which we have started working, and even when we buy cell from abroad, we don't know who is the manufacturer. For example, in China, there are hundreds of cell manufacturers, like we have Lijjat Papad manufacturing across the country, and we don't know who is supplying this, what is the quality. So every time a vehicle manufacturer receives the cell from abroad, they may receive it from a single company, but they don't know who has actually produced them. And it will be very difficult for them to characterize each and every lot. So we will have to first characterize the base from the supplies, from different supplies. There are 3-4 suppliers from whom every company buys, so that they are not dependent on one. We need to characterize, come out with a common specification, and then with respect to that, in future, whatever cell comes, we need to characterize them and compare them with the baseline. And there is a huge demand, and against that the supply is very less. So there is a monopoly that whatever we give, you have to take it, you have no other option. And since automotive industry wants to sell electric vehicle, they are also keeping quiet. So this is one lacuna where we cannot check each and every cell. For example, if I want to check a cell for 1000 cycles, charging and discharging at just 1C, it will take 1 hour. And if I am going to talk about numerous cells, it's going to take months together to do this. So we will have to work on an area where we can do it faster. So the solution could be with battery computational material engineering with AI, And battery analytics is another area where we need to work on, which can reduce the development time, development cost, and this will be the way by which we can link up the missing link and find out a solution. So we have been working on all this area of battery analytics, and I must tell you that of last 2 years, we have been collecting a lot of data from the fresh battery, the old batteries, and based on that database, we have been able to collect aging data at the calendar level, at the cyclic level, at the vehicular, that is driving cycle level, and all this data has been collected and put into a model which uses the thermal model, equivalent circuit model, electrochemical model, and physical model. And what we call this as a DigiCell, and this DigiCell is available, which is just 3% of the computer cost. There are modules available abroad. Compared to that, it is just 3%, whereas it is 3 times faster in terms of analysis. So we all need to work on this. So basically, every battery must have a passport, and this passport is possible through blockchain technology, which will enhance transparency, traceability, and sustainability in the data management. Today, there is no trust, and to have that trust, the common data has to be put in blockchain. This will improve the trust among all of us, the manufacturer, the suppliers, the vendors, and will bring in transparency, traceability, data integrity, smart contracts, and interoperability. So we all need to work towards this. A lot of data needs to be collected on blockchain and analyzed. And finally, it is like we call it as an Adar system or an Adar card, a passport or an Adar card of a battery. And this is the what government calls it as the e-mobility R&D roadmap for India. And battery Adar is a digital record that contains data about every battery which is available in the market, battery and its cells and the modules. And a global battery alliance is conceptualized for the battery passport as a framework to increase this transparency. So this will go a long way for us to reduce our dependency on quality control of the cells and the battery, and we need to work in this market. Just last couple of slides. There are companies like Amar Raja Battery, Exide, Ola Electric, Reliance, Tata Chemical, Log9. They have been working in this area, and the progress, I must say, is very good, and I can see the light at the end of the tunnel within couple of years. So with this, I complete my presentation. So this app which we have developed is called a Good Life app. My co-founder is here, Ajit Babu. I would like to call him on the stage. And in case anybody, any automotive industry needs any support for characterization of the cells and batteries, they can contact us. So thank you very much, and we look forward if there are some questions. Thank you very much.